Okay, in number 11 here in the first section of chapter 3, they're asking us to find when does this function have a slope of a tangent line that's equal to the square root of 2. And so, normally we typically would ask you when does this have a horizontal tangent, and then that would be a slope equal to 0. But in this case, they wanted us, for some reason or the other, to find the value that gives it a square root of 2 for the slope of a tangent line. So, anyways, we're going to do the same thing. We're going to take the derivative of the function, and of course, using the power rule, that would be 3 times x to the 3 minus 1 power minus 3 times 2 x to the second power minus 1. And of course we get 3x squared minus 6x to the first power. And in this case we're going to set it equal to the square root of 2. So, well, how are we going to go about doing this? Suppose we could try to factor out a 3 from the left side, but that really wouldn't get us very far. So hopefully you've probably done this before, hopefully in pre-cal or algebra 2, where you set this equal to 0, and if you're going to solve for x, you're pretty limited. One approach would be to use the quadratic formula, the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. In this case, a would equal 3, and b is equal to a negative 6, and c would equal the negative square root of 2, right? Well, that's kind of cumbersome to put that all into the calculator, because you're going to certainly need that to get you the correct answers. Well, another way to do that, of course, would be to put this expression into the graphing calculator and use the calculator to find the roots or the zeros. So that's exactly what we're going to do in this video. So let me get my calculator turned on over here, and we'll put the function in. Here we are. So we have 3x squared minus 6x minus the square root of 2, and we'll graph it up, and you can see that this has 2 roots. One of the roots looks like it's a little bit to the left of the origin, and the other one is somewhere past 2 somewhere. So anyway, let's get this down. So we'll go to the calculate section, and we'll look for number 2 and find the 0. So if you haven't done this in a while, remember, since we have 2 roots, we have to make sure we're in the right region when they're asking us the questions. The first question they're asking us about the left boundary. So that means I'm to the left of the root that I'm trying to identify, and I'm just above the line, so I'm to the left. I think I hit enter too fast. Let's try that again. Second calculate and 0. So the left boundary, having trouble with this calculator. Let's just do it like that. And then the right boundary, I need to come down till I am past the x-axis, but not past the vertex. So you can see where I am on the screen, hopefully. And then hit enter a third time, and my first root is at a negative 2.13. So let me record that. Whoops. X is equal to negative 0.213. That's the first root. And let's take a look at the second root. So we're going to go second, calculate, and 0 again. And now we have to move our cursor over so that we are past the vertex but underneath the right-handed root, and then move it above the x-axis. And then we find out that the second root is at when x is equal to 2.213, sorry. So these are my two values. X is equal to positive 2.213. Alright, hopefully this was helpful. You certainly could have used the quadratic formula to find your two x values just the same way. But I think the graphing calculator might be a little quicker in this problem. So anyway, hope this helped. Best of luck on the rest of this